All right, so today you're going to talk about solving exponential equations that have a common base. And when they have a common base, it's very easy. Once you get that common base, you go ahead and drop those bases, just set the exponents equal to each other, and then solve for x from there. So let's go ahead and go through this. So for this one, you can see that the bases are the same. So they both have a base of 2. And because of that, that means that you can just drop those bases and just set the exponents equal to each other. So x plus 1 equals 9. So in this case, x would equal 8. Okay. Same thing for the second one, right? They have a common base of 5, so that means those bases will drop. So you get 4n plus 5 equals n minus 7. And so we'll subtract the n on both sides. So we get 3n plus 5 equals negative 7. Subtract the 5 on both sides. So you get 3n equals negative 12. Divided by 3. So n equals negative 4. Okay. When they have the things when they have two bases on the same side, like in this case, well, those bases are being multiplied. Well, anytime you have things with the same base being multiplied, it means you add their exponents together. So you have 2k plus 2 here equals 5k minus 1. Subtract that 2k from both sides. 2 equals 3k minus 1. Add the 1 to both sides. The 3 equals 3k. So k is equal to 1. Okay. Same thing on this side. Common base on the same side being multiplied, that means the two exponents get added, so it's negative 4 plus 9. Common base on these two sides, the same thing, so the exponents get added, and everything gets, because they're all the same common base, same thing, all the bases get dropped. So there you go. So we get 5 equals 3v minus 7. We're going to add that 7 over. So 12 equals 3v. So 4 is equal to v. So that's nice. Everything's been nice and easy. The bases have always been the same. So let's go ahead and try it when the bases are not the same, like in this case. When the bases are not the same, what you have to do is you have to take the biggest number and make it to have a base of this base over here. Well, I can make 36 be 6 squared. So because I now made it with the same base, same thing, now you just do it the same way. Those bases drop. 2x minus 10 equals 2. Add 10 to both sides. So 2x equals 12. So x equals 6. Same thing over here. I can change 8 so that it has a base that is 2 by doing 2 to the third. Okay. So now that they have the common base, those bases will drop. So it's p minus 7 equals 3. We're going to add 7 to both sides. So p equals 10. And then these last examples, same thing. We have 2 more examples. So same thing. So 8 and 32. I can turn 8 to be 2 to the third. I can turn 32 to be 2 to the, say, fifth. Okay. And what that's going to do is now it's going to be multiplied to whatever exponent's currently up there. So now they both have a common base of 2, so those bases drop. So it's just 3 times 2a minus 1 equals 5 times 2a plus 1. And it's just solve for a. So you got 6a minus 3 equals 10a plus 5. Subtract the 6a over. So you get negative 3 equals 4a plus 1. Add the 1 over, subtract the 1 over. So you get negative 4 equals 4a. So a is negative 1. Same thing for the next one. 27, the smallest base I can make that is a base of 3 by making it 3 to the third, and again it gets multiplied to the current exponent that's there. 243 then, that means I got to make that a base, so it's kind of a guess and check game, so I'm going to try 3 to the 5th, and 3 to the 5th is 243. Again, it gets multiplied to the exponent that's currently already up there. So now that they have the same base, those bases drop, so it's 3 times 2x equals 5 times x minus 2. So that's going to give me 6x. It's going to give me 5x minus 10. Subtract the 5x over. You get x equals negative 10. Okay, last couple. And this one, they use properties, so you got to use properties. So first, let's combine, because these have the same base, what we're going to do, it's going to be, that's for the first, all right? So it's 4 to the 1 plus 4x, meaning I added the exponents. You know my 64. Now, I want to change 64 to a base of 4. And 4 to the third. And now that they have the same base, those bases drop. So it's just 3 equals 4 plus 1 plus 4x. Subtract the 1 over. So 2 equals 4x. So x in this case would be 1/2. And then same thing over here. They have the same common base already. So we're going to go ahead and add their exponents together. So 2x plus 4 plus 2x equals 1 over 81. Now, 1 over the 81 is the same as 1 over 9 squared. But remember, when you have 1 over, that's the same as 9 to the negative 2. So really what you're saying is you have 9 to the, and I'm going to go ahead and combine them, 4x plus 4 equals 9 to the negative 2. So now that they have the common base, drop it. So 4x plus 4 equals negative 2. Subtract the 4 over. So you get 4x equals negative 6. So x equals negative 6 over 4, which reduces to negative 3 over 2.